Hi, now let's talk about the for loop and while loop. Let's first take a look at the for loop. A for loop steps through each of the items in a collection type, like string, a collection of characters, letters or numbers or other characters, a list, all the items and elements in a list, and tuple, okay, or any other type of object which is iterable. So that means any type of object that had different elements and order. And the program can iterate through each element of the data type. We can use the for loop to go iterate each one of the items. So for each item in this collection, you do something, which is a statement. If a collection is a list or tuple, then the loop steps through each element of the sequence. If collection is string, then the loop steps through each character of the string. For example, some character in Hello World, and you print out this. This is Python 2's code. It should have a parenthesis around it in Python 3. Let's see what's going on. If we have for character and say hello, then you print out character, and you will print out every character in turn. Okay. Where is it? Okay. The second one. Where's my mouse? Okay. The second one is for the second slide here. The item can be more than a single variable name. When the collection elements are themselves sequences, then item can match the structure of the elements. For example, here, if you have, you can search each of the tuple for the tuple in the list of tuples. So it's going to iterate not just one variable, but a pair of variables, x and y. And you do not have to print out both x and y. You can just print out x. Let's take a look. What's going on here? Oh yeah. It should have quotations to make it a string. Okay. Then you can print out the A, B, C, D. If you want to print out Y, you can also print out 1, 2, 3, 4. What if I want to print out, like, say, X, Y, Y, X? Can I do it? Yes. So the XY pair go through each of the tuple in this list and stores each value in each iteration. And you can make any combination and print out whatever you want using the elements, the values of X and Y. You can also use the range function. The range some number returns a list. To be very rigorous, it's a list-like, pseudo list-like variable, which is not really a list, but it works like a list. Okay. When you wanna iterate through a sequence of numbers, this is very useful. For I in range 10, you print I, and you will print out from 0 to 9, but not including 10. If you want to print out from 5 to 10, it's going to print 5 to 9. Okay? And if you want to print from 5 to 29, and you print every 3, so every 3 numbers, the interval should be 3. When you first print out 5, the next one should be 5 plus 3 equals 8. Then you print the next one after 3, so it's going to be 8 plus 11 equals 11. 8 plus 3 equals 11. Okay, until the last number in this range between 5 and 29. For dictionaries, you cannot just print out dictionaries directly. The reason is that dictionaries are not ordered. It doesn't really have order. You cannot really iterate through the sequence without with a collect. Actually, it's a collection, but the collection doesn't have order. So you cannot. It's not a sequence actually. So you cannot iterate through each element of this. If you want to do it, remember that when we learn dictionaries, we can use dictionary.keys to retrieve the collection of all the keys. You can also use the values to retrieve all of the values. You can also use items. Well, let me just copy this. And well, let me update it. And there was okay. There is an easier way of doing this. Just items. First, I want you to know that what the age. I want to remind you what the ages.items return. It's going to return a list of tuples. Okay. Actually, you can write the program like this. For key value in this, and you print key and value, and you can print the value twice. See? Okay. And you can also just print out the key or value. While loops. Another type of loop is a while loop. The while loop repeats a block of code until a Boolean expression is no longer true. So remember that for loops, you always have a range for the I or the name, or here the X, or here the pair of X and Y to iterate, to begin with, to end within a range, and you have to specify where to begin and where to end. For example, here you begin from 0 and end at 4. Here you begin from A1 and end at D4. Here you begin from, because ages.keys returns Sam, Mary, and Bill. So you begin with Sam and end with Bill. It should be maybe you should start from Bill and end with Sam, because ages the keys probably will return a list with the first element as Bill. But what if you don't know where to end and when to end? What do? You can basically ask the program, use the while loop to ask the program to execute some statements whenever the Boolean expression is true. For example, you can write some Boolean expression here. While it's true, you do something. Okay, like But there will be a problem. For example, while like x is 1, x is like 5, and while x is positive, we do print positive. What's going to happen? In the first iteration, x is 5. Because x greater than 0 will return a true. So while true, you will print positive. Then what? Then we go to the next iteration. In the next iteration, x is still 5. And you will print out positive again. And then the third iteration, the 10th iteration, the 10,000th iteration, you always have x greater than 0 as true. So you always print out positive. So the loop will never end. See? It never ends. What do? Do we just wait here? Or we just, what do we do? Can we just stop Python? You don't have to. You can do several simple things. For example, here, there is a stop sign here. You can basically stop it. And you're going to just break the whole iteration. Or there is a hotkey here. Like, let me do it again. Okay? You can use Control, you press Control plus C here. And it will give you the same effect. Now let's continue to look at the while loop. So what if you want to use a while loop but you don't want the loop to go forever, to iterate forever? You need a loop counter, okay? So first, you want to initialize a counter, for example, I, as 1. And every time you do something, you increment this I by 1. Because while loop, the condition of the while loop is whether I is smaller than or equal to 10. So in the end, by the end of some iteration, I will increase to finally above 10 and the whole loop will be ended. So here, let's counter as 1. As we say, while count is smaller than or equal to 10, we do print count. And count equal to count plus 1. Okay. You find that at the first iteration, count is 1, so you print out count as 1. And after executing this statement, we increment the count by 1. So here, at the end of the first iteration, count will be 2. Okay. Now, count is 2. Is count smaller than or equal to 10? Yes, because 2 is more than or equal to 10. Then you print out 2 again. Then count is incremented as 3. Then you do this and you do this whenever count is 9. Then you print out 9 and you increment count by 1 and you got count as 10. Does it over? No, because at the final iteration, count as 10 is equal to 10, which is more than or equal to 10. And you print out count again, and count will be 11. And the count smaller than or equal to 10 condition is not satisfied, it's not true, it's false. So the final statement will, the statements will not be executed and the loop will end. Here, if we check the value of count, we will find that it is 11. Okay. This is another while loop example. If you want to print out 3 6, 9, 12, what do? You first initialize count as 1 and num as 3. While count is more than 5, you print out the 3 times count. So when count is 1, you print out 3 because number is 3. And after executing the print statements, we increment count by 1, and count will be 2. So 2 is more than 5, and 2 times 3 will give you a 6. And then you increment count by 1. Count will be 3, and you print out 9. 3 times 3. Then you print out 3 times 4, and here count is 5. Well, when count is 5, 5 is not smaller than 5 because it's equal to 5, and the while loop will stop. Instead of using count equals count plus 1, you can also use count plus equal to 1, which is a simpler way of writing the increment, the increment statement. Say here, you can just write let's say 20. Oh, it's because we could do 1. It should not be, let's say, 50. Okay. It starts from 22 because it was 11, and 11 plus 11 is 22. So it starts from 22, and it goes to 50. The reason we have 50 here because we make the condition as count smaller than or equal to 50. If it's smaller than 50, then it will the last number being printed out will be 49. Okay. You can also write increment you don't have to have the count here because you can basically modify this code and change count equals count plus 1 as number equals number plus 3. Okay, and print out the number. You can also print out the 4 identical numbers. Okay. So this is another example of the loop counter, and you can practice it by yourself. Notice that we initialize a loop counter to 0 or 1 or whatever you want to start with, and test the loop counter in the Boolean expression. Is it smaller than 10? Here. If yes, then keep looping, keep doing the iteration. And you always do not forget to increment the loop counter as 1 or as whatever number you want to add to it every time you want to go through the loop. If you miss any of the 3, the loop will never stop. Okay. There were some other useful useful statements that you can use. The first one is break. The second one is continue. The third one is I think it's a third, but oh, it's a third here. I'm not sure why it's not why it wasn't on. So break. Okay. Let's take an example. I was writing a code. Here. See, this is some code, and we just assume that count is 0, and well, we want to say while count is smaller than or equal to 20, we print out count, and count every time increments by 1. So what will this print out? It will print out from 0 to 20. Okay, from 0 to 20. What if I want to wanted to stop at 15. You can always check at each iteration. By the way, I need to reinitialize this count. And after in each iteration, you want to check if count is greater than or equal to 15. If it is, then you break. So when count is, for example, 10 for any number below 15, will this statement being triggered? No, because if count is smaller than 15, it will not be triggered. Okay, the condition is not satisfied and the statement will be skipped. And you will just keep printing from 0 to 14. Whenever count is 15, well, because count is smaller than or equal to 20, so 15 will still be printed. 15 will be printed, but since 15 is equal to 15 here, the condition is satisfied, the break will completely makes it jump out. Will jump out of this loop, and the the numbers from 16 to 20 will not be printed. Check it. See, still 15. And after 15, when count is 15, then these will not be counted. Let me modify the code a little bit. What does this code will print you? Will print out. So whenever count is 0, okay, this will not be. It will be skipped. It will not be executed. So you will print out 0. Then after this iteration, count will be 1. And since 1 is smaller than 20, then this will not be until. So you print out 0 until, say, 14. Okay. When 14 is smaller than 20, this will not be executed. And you print out 14, and count is 15. Okay. Because 15 is equal to 15. And here, from here, the whole loop will be stopped. Okay, we will jump out of this loop, and the things print was before the if condition. If then the conditional statement now is below the is after the conditional statement. Then 15 will not be printed out. So it will print out from 0 to 14. From 0 to 14. What do we have if we let's read. What do we have if we have continue here? Okay. This is a question I wanna. You should stop this video. You should pause this video and have 10 seconds to think about it. What do we have if we just change it to continue? Remember that continue means that inside the loop, you stop processing the current iteration of the loop and immediately go on to the next one. Remember that we're not jumping out of this iteration, this loop. We just skip the parts after continue. For example, it's skipping this one and directly jump to the next iteration here. Okay, 10 seconds. Pause this video. Think about it. Okay, let's run this code and find that actually it's going forever, and we stop it. The reason is that the reason is that for the above code, count was 0. Count was 0, and it's yeah. count was 0, and when the first time you print out, then it's in the first iteration, count was 0, and you print out 0. Then if, well, I think in the above code I mistakenly this one. Okay, this could be right. And in the first iteration, you print out 0, and 0 is not greater than or equal to 15. So this statement, the continuous statement, is not executed. And then you increment count by 1, and count is 1. Until count is 15, you print out 15, because 15 is still smaller than 20. Then you print out 15, and 15 is now greater than or equal to 15, because it's equal to 15. So you continue. When you continue, you are not executing the rest of the statements in this current loop, in the while loop. So therefore, it is skipping this statement and directly go back to this while loop. And count, since count is not incremented, count is still 15. Okay. When it's still 15, it prints out 15 again, and it will continue and go back to the loop. Then the loop will never stop and goes forever. That's why you see a lot of 15s being printed out. To modify this code, what you should do? You first make print count as 0. You initialize it again, and we want to increment the count at the beginning. Okay, now you print the end. What do you find? In the first iteration, count will be 0, and you will have count increment by 1 first. So count is 1, and you print out 1. Since 1 is not greater than or equal to 15, you will print out the end. Then you go back to the loop, and when count is 1, the count now is incremented by 1, so it's 2. And you print out 2, then the end. Until count is 14, you increment count as by 1. So if count is 15, you print out 15. You do not print the end, because this statement, this condition is satisfied, so this statement is triggered. And continuous statement skips the print the end. So you print out 15, then you go back to the loop. And 15 is more than 20, but now 15 is incremented by 1, because the count becomes 16, and you print out 16. Again, 16 is greater than 15, so statement will skip the last print the end statement. Then you go back. So then the end will only be printed after from 1 to 14. Okay, then for 15, it's going to print out 15, 16, 17, 18, 19. When count is 19, you go back here, and you find that count is incremented by 1, so it's 20. Then you print out 20, then you go back, because 20 is equal to 20, and you print out 21. So from 15 to 21, you only print out the number, but not the end. Okay, let's see. Right? So you print from 1 to 14, together you print out the end, but from 15 to 21, there is no the end being printed out. Okay, so this is continue. Continue will stop processing the current iteration of the loop, but immediately go to the next iteration. While break just stops the whole loop and jumps out of the loop. The last one is assert. An assert statement will check to make sure that something is true or not. If the condition is false, the program stops and throws an exception. For example, if the number of players smaller than 5. let me check the assert. This is something that I wrote before. Where is the? Yes. Take a look at this loop. Well, we should initiate count as 0 and take a look at this loop. You first print out the count, and you always increment the count by 1. And before the incrementation, you assert, and you want to check whether count is smaller than or equal to 15. Okay, if it is true, if count is smaller than or equal to, actually you don't have to use the parentheses, you can just use this. If it is true, then it doesn't do anything. If it's not, it will just throws an exception. It's not just a break. Break will make you just jump out of this loop while not stopping the whole program. It will jump out of the loop, but after the while loop, if there are some other statements, the other statements will still be executed. But for the assert, the other statement will not be executed. For example, if you have print other statements, okay. So you will print it, count from 0 to 16. When count is 16, when count is 15, you print count. Then you assert count is more than or equal to 15, which is true. When it's true, it doesn't do anything. And count is incremented by 1, so it's 16 now. And when it's 16, you print out 16, but the assert statement will find that 16 is not smaller than or equal to 15. So it just throws the exception, and the whole loop, the whole program will be stopped. And the other statement will not be executed. But for break, if you do if not, okay, if not, break, because this count should be initialized again as 0. It's going to print out from 0 to 16 again. The loop is jumped out, but we still print the other statements, okay, parallel with the while loop. Here in the assert, if we use assert, then the other statement will not be printed out. When do we use this? In debugging. Okay, sometimes in a very, very long, here we have the pretty short, for example, this, in the editor, this code is only like 20 lines. In some codes, there are like 5,000, like 2,000, like 500 lines, which is pretty long. And whenever you have bugs, you don't know when they have bugs. So you want to put the assert into the loop and check whenever the condition is not satisfied, and whenever you wanna stop the code. And because you're debugging, you don't have to execute all of the other statements under this code. That's why you need assert to stop the whole program. Okay, but assert is not a very easy not an easy statement to use. So the programmers around the world, they developed the open source package called AssertPy. And from the AssertPy, you can import some other, because for this assert, when it jumps out and stop the whole program, you only know that something is wrong here, but you don't know why it's wrong. Here, for example, it only gives you that this is wrong, and it's assertion error, but it doesn't tell you what error it is. It just tells you that this condition is not satisfied, but why it's not satisfied, what it should be satisfied. So in the package, there were some other statements or functions that you can use. You can import this function and use it. It's gonna give you the hint and warning why this it's a hint that why this condition is not satisfied. When we are learning packages, after learning that you can install it by yourself using a pip install and research on that. So this is the end of the for loop and while loop, and in the next video we will do the exception handling. Okay, this is the end of this.